Welcome. Before we start, disaster struck. This is a drawbar of my milling machine. And if you look at the end here, get the camera to focus. This nut is broken off. Now what they've done is they've taken a 12mm rod, threaded the one end, machined down the other end, and put in a cross pin in there, and that pin broke out. Now it was also welded after the cross pin was put in. You can see there's a hole in the nut, and the welding broke off and it came loose. Now this design, I don't agree with it, because now if it was me, I would have made this a thread and then cross thread it. So yeah, but in the meantime I've made a plan. I've taken a piece of M12 all thread, put a straight 12mm nut on there, and cross drilled it, tapped it, and screwed in a 5mm or M5 screw in there, and just cut the ends off, and it works perfect. So by the way, this is a 8.8 grade, so it should be fine. Okay, now we can start. This project is very simple. I've got a piece of cast stock in here, and what I need to do is to make the tube clamps for a standard curtain rail, which is 16mm in diameter. Now this is going to be used outdoors for an awning that I'm busy making for my son, and I prefer to use the aluminium tube so that it doesn't rust on the material that's going to be used. I'm using a type of canvas, and how this is going to work is, on the one side you can have a self-tapper that screws right through into the frame. I've got two A-frames on the side, on each end of the awning, and the other side is not going to have it, what's its name, a self-tapper going through, but only a clamping screw. So this, I'm going to slit it on the one side with a hole in the middle. So yeah, you will see it's very simple. Now I'm just going to do a light cleanup on this, because it came out reasonably square, so it's not a lot of machining to do on it to get it square. And I'm using my pallet table again, because I just love the setup, and it's also more camera friendly in my opinion. have my mini vise clamped on the table right next to my engineer's parallel, and that will act as a stop in the back. It also keeps the vise square. Got two end mills in here for bottom clearance. So quick and easy setup, very repeatable. Okay, I was doing these drill or the sizes that I've drilled was in steps. I started off with a 10 millimeter drill, went up to 13 millimeter end mill, 15 millimeter end mill, and then 16 millimeter end mill as a final size. That keeps the run out of the end mills, especially on the last cut, to a minimum. One thing I like about the end mill is the fact that it leaves a better finish than a drill bit. As you can see, it's a nice and tight fit, and that's exactly what you need. The rest I will do off camera. As you can see, it's a very repeatable setup, and it's quick and easy. Okay, I've drilled all the holes on the one side because this particular hole is offset by 1 millimeter towards this end. Now on this side is where the self-tapper is going to go. On this end is where the clamping bolt is going to go in. And on this end I'm using a M6 cap screw. And this end is just a 4.6 millimeter self-tapper. The shaft of the self-tapper is 4 millimeters, but threads works out to about 4.6 millimeters. So I've opted for a 5 millimeter hole, and I've offset the hole here as well to cater for this bolt. These guys are all done, and I've tapped them off camera and deburred the insides, the slots, and I think they're going to work very well. Hope you enjoyed this build. For a simple part like this, it's quite a bit of work, because the most of the work goes into tool changes and repositioning the part for the different faces. But yeah, until next time, cheers.